Welcome to Intro to AI with MS Semantic Kernel. So this is an introductory level course for AI. My name is Mike Yeager. I'm CEO of Code Consulting. I've got 20 plus years of experience, and we won't say how many pluses. It's a lot. I've also done a little bit of writing and some speaking. And if you need to contact me, it's myeager@codemag.com. Feel free. We're always looking for people to reach out. A little bit about who we are. We just celebrated our 30th year in business. I had a big event down in Orlando, which was great. Had people come in from all over the world. And no matter what part of code it is, we're always just helping people build better software. That's what we do. So whether it's consulting or staffing or the magazine, which you're probably familiar with, or one of our training sessions, that's what we're all about. As far as the consulting side, that's the division that I'm in. It's a large part of our business in the past has been legacy conversion project, a shocking amount of Fox Pro work, custom software development. But it's the second bullet point that is really interesting. We've been doing a lot of that lately. Everybody's interested in AI, whether it's machine learning or speech to text or GPT or whatever the flavor of AI. Right now, copilots are the rage because they're relatively easy, small projects. They can happen fast, and they provide a lot of benefit for a little bit of effort. So if you are interested in AI, come check out these two links. The first one is just a general link about all our AI offerings. The second one is about an executive briefing. And that's where we'll sit down and talk to your management people and your executives. So it's not really a tech talk. It's more about that high level, getting these projects going, overcoming some of the barriers. And we can answer those questions like, is AI safe? And what can AI do for us exactly? And is it expensive? And I've heard that it makes things up. So all those concerns that they have can be addressed. And that can be anything from a multi-hour in-person event or just a brief 1-hour online remote meeting. So contact us about that, and you can find out information at that codemag.com/executive briefing. Real quick word about code staffing. So our staffing division is relatively new, and they are turning the staffing world on its side. It's really a whole different approach, which is kind of nice. So if you work with staffing, you actually get employed by code staffing. So you're a real valued employee and you're treated like a valued employee. You get vacation benefits and training and all that good stuff. So if you're a dev looking for work, we'd love to have you come join us. If you're a company looking for people to come work in a staffing situation, give us a try. Our people have the entire code organization behind them, and we're getting really good results. People are really happy with it. It's not your traditional staffing gig where people aren't all that thrilled to be there. So it's really cool. Check it out. If you are interested in getting a career with code staffing, it's codestaffing.com/careers. So I encourage you to go visit them. Real quick word about the things that are coming up, some other code presents. So we have a session about Photino, which is an alternative to Electron, if you know what Electron is. It allows you to build applications with an HTML front end. So it's sort of a web application that runs in a native window. And so there's things like VS Code was an Electron app, and the original Teams was an Electron app. So there's a ton of them out there. But instead of building on top of Node.js like Electron does, Photino builds on top of .NET. So you have the .NET framework running. And really cool project. After that, January 30th, we have development with Azure OpenAI, GPT, and DALL-E. So all that AI stuff that you can get through Azure. So this is kind of like what OpenAI does, like ChatGPT, but these services are actually provided by Azure. So in a business environment, you can, be set up with an account and you work through that, and you're not going through just the generic OpenAI stuff. So you get all the benefits of Azure, and it's really, really cool thing. We're going to show you just a taste of it today. But if you want to learn more, that's Marcus on January 30th. And then we also have the State of .NET coming up. That's one that we do every year and kind of tell you what's going on in the .NET world. This year it's all about AI. So of course, State of .NET AI 2024, and that's February 28th. So come join us for that. Everybody who's here today probably knows about the magazine. If you haven't, it's a great hands-on sort of nuts and bolts magazine. Gets down into the code, and you get a free subscription for a year. So you can go ahead and feel free to share this link. It's a bit.ly link at the bottom there. So go ahead and copy that. And it'll be in the slides if you get those later as well. And get a free magazine. All right, what are we here for today? We're going to talk about semantic kernel, what it is, why do you even care about it, what other frameworks are out there, what's in these frameworks, and then we're going to get into some coding. So I got a few slides to start with to kind of get you situated and oriented to what we're going to be doing, and I'll talk about some concepts, and then we'll dig into some code. So what is Semantic Kernel? It's an open source framework. It was created by Microsoft, and it's for working with large language models. It's interesting because Microsoft says it's at the center of the Copilot stack. So it's what Microsoft uses to build their Copilots. They needed something that was a little more structured and had some nice features in it so that they weren't coding everything by hand, so they had some consistency across their copilots. So this is sort of what they came up with, and they're sharing it with us. First thing you might ask, and it's a good question, is do I even need a framework? Well, no. I mean, like any other framework, you really don't need a framework. Frameworks are there to help you out. So if you're doing relatively straightforward and specific things, you might be better off just hand coding it and being able to tweak it down to the smallest detail. And for simple things and things that don't change and don't require a lot of lateral thought, I think that's a fine way to go. Frameworks shine when you have multiple APIs, so you're hooking up to, say, Hugging Face and OpenAPI and Azure OpenAPI, and you've got a bunch of different models that you're working with, and you got a lot of different tools that you're working with. And when you start building more complicated things, there's actually a significant amount of code. There is a lot of code, and a lot of it's just nitpicky plumbing code, and you end up writing things that you reuse. And frameworks kind of abstract away all that stuff. So it's kind of nice to get started with a framework. Maybe not your hello world, but once you start developing a real AI application, it's a great way to go. And I really like the semantic kernel framework. It's kind of nice. So you just get this higher level, more consistent way to get the job done. And I mean, that's kind of what frameworks are for, right? So semantic kernel is just a framework for doing things with LLMs. And Microsoft actually calls it an SDK, but it's pretty big. So we consider it a framework. There's some other frameworks out there. Semantic kernel is Microsoft's version. And there's one that's been around for a little bit longer. It's called LangChain. And so it's probably the most popular framework for LLMs, and there's a link up there. What's interesting about that is that they do Python and JavaScript/TypeScript. So if you program in those languages, you've probably heard of this one, you've probably used it. It's powerful and mature. There are ports of it. There's even ports of it to .NET, and it's a pretty cool framework. Semantic kernel is, like I said, Microsoft's version, so it's a .NET version. It's mainly C#. There's also a version in Python and a version in Java, and it's incomplete, but it's moving fast. At this point, they're approaching a V1. They just this week are in. They've gone from betas to release candidates. So they went from previews to betas to now they're in release candidates. And there's one coming out, seems like about every other day, a new release candidate. So we're pretty close to V1 at this point. So this is kind of the big slide. This is the one that's got all the content in it. I know there's not a lot on here, just a few words, but this is where we talk about all those concepts. So what is in the frameworks? The first thing is, there's this whole discipline of prompt engineering. You've probably heard about it. There's books written about it. There's courses on it. The better you can write your prompts, the better your system works. And there are tricks about how to write prompts and make those work. And what's weird is that we've been hand coding these things for quite a while, and oftentimes you'll just see the prompt just kind of stuffed in as a string right in the code. Wouldn't it be nice if when you develop these prompts, you can test them and put them in a library and reuse them? That's one of the first things you get with the framework, and it's what they call semantic functions. And semantic, I mean, the word semantic is, it means, about language and understanding. So these are natural language ways of programming. So when you build a prompt, you're actually programming, but you're programming in our case, English. And even though it's pretty good at translating between languages and it understands different languages, I'm saying most of the models that we'll be talking about, it's still a natural language. So instead of C#, you're kind of programming your prompts. You're doing prompt engineering, and you're going to come up with this library of prompts that you can use, these semantic functions, and use them across various applications. So the other thing that's part of that is a templating engine. So these prompts are sort of like text merge documents where there's the whole instructions behind the prompt, and it says write a poem about, and then you kind of fill in the blanks. So we built our own templating engines originally, and now that's all kind of built in. We actually have some options for templating engines. The next thing that we have is something called memories, or that's what Semantic Kernels calls them anyway. And you probably heard about grounding a model or using the RAG pattern, the retrieval augmented generation pattern. If you use ChatGPT, you know that it used information from the internet to train, and it's trained up to a certain point in time. And that all works great if you want to know things like what's the capital of Florida. But it won't help you if you want to know something from your company's employee handbook, or if you want to know something that's stored in your database. In those cases, you need to retrieve some information first. Then you stuff that information into the prompt along with a question, and then ChatGPT can use it to produce a nicely worded answer. So that's kind of the second thing is memories. Next, if you want to do something more than generate text, I mean, if you want to look something up using Google Maps or generate an email or do math or make a reservation, then you need some way to do those things. And LLMs are great, but they pretty much only generate words. So there's a lot of names for this. They call them connectors and agents and plugins. Semantic Kernel calls them plugins, and you can use other people's plugins. You can create your own plugins, and these things are called very much like the semantic functions are called. So these are called native functions or plugins, and as far as calling them, you'd call them in the same way. So you pass in some parameters, it does some work, and it sends something back. So no matter whether your code is C# or if it's English language in the form of a prompt, they're kind of treated the same way, and you execute them the same way. So plugins is the next big feature. The next one, I don't consider this a big feature, but it's definitely something that'll save you a lot of time. So I included it here. So it's not one of the big four, but utilities. So you might ask something like your AI model, your copilot, do I get Christmas Eve off? And you can't really just stuff the entire employee manual into a prompt in most LLMs. It's too big, it's not very efficient. And if you get a link to it and they click on it to go look it up, it'll just take you to the first page of the manual. So what we do is we chunk these things up. So we have utilities, and we've all written a few of these if you've been doing this for any amount of time. We did some by hand originally, but now there's utilities that'll handle this for you, and it's not that easy. So it's like, well, how do I cut this up? And you might say, well, we'll just take every 500 characters, but that's kind of a random way of doing it. Works better if you say, well, let's go to the end of a sentence if possible, or to the end of a paragraph if possible. And what if you have a really long paragraph and it's too big? Then you have to cut that paragraph in half. And what if you cut it on the paragraph mark, but the thing you're talking about is begun in one paragraph and then it's continued in the next paragraph, and you have this situation where some of the information's in one and some is in the other. So then you want to do things like have a little overlap between when you cut these things up so that you can include a little bit of the previous and a little bit of the next paragraph in the paragraph that you're sending off. So, I mean, it's tedious work, and there's a lot of little details to it, and you just keep tweaking your chunker over and over again, making it a little bit better. And so it's kind of nice that there are just some that are in there for you. So that's one more thing that's in these frameworks. It's going to help you with that. All this stuff is going to cut down on the amount of code that you write. And the last thing is this ability to plan or chain prompts together to achieve a goal. So if you have a complex question, say it's difficult to answer in one fell swoop, then it's not something that is going to be easy for these tools to do. And if part of what you need to do is to go out and work with plugins, then you can't just send everything to an LLM all at once and have it, process the entire thing and deal with all the plugins at once. So just like anything that you do, if it's a complex thing, you break it down into steps. So if I was to say, oh yeah, I want to take my wife out and we'll have a date. I want to go to the best restaurant in town. Let's make a reservation. Well, there's a bunch of things involved in that. One of them is, where am I? I mean, I may not be at home. So if I'm traveling, what city am I in? And I might need a plugin that maybe looks at location services and goes out and says, oh, I see where you are. You're in Orlando this week or wherever, and it says, this is where I have you. Okay, now what are the best restaurants in the area? So that might be a web search, and I go out and find the best restaurants, and I might find information like, are any of them closed today? Oh, it's closed on Tuesdays, so we can't go there on Tuesday, but we can go to some of these others, and then maybe it will download the menus so that it can say, well, here's a couple of choices. Which one do you like the best? And I say, oh, I like that one. There's a nice French restaurant. So this whole series of steps, and then you figure out, pick which restaurant you want to go to, and then you want it to go off and make a reservation and put it on your calendar. So that complexity and that ability to move from one thing to the next to kind of solve this puzzle is another feature of these frameworks. And when we get to the end, we'll talk about planners, which is where you kind of hand off that whole process of coming up with these steps to the large language model. And we'll show you how that's done. So those are the big things. You've got prompting, what we call semantic functions, and then you've got this ability to deal with the outside world with plugins. You've got memories, which is this ability to go look up data and incorporate it into your queries. And then at the end, this ability to tackle complex things with a chain of prompts or a plan. And then, of course, we have some utilities. So that's what we're getting out of this. And we'll take a look at all of those things. So where do you go find it? How do you get this to work? There's the GitHub repo. It's all open source code. When you download it, there are a bunch of Jupyter Notebook samples and a bunch of .NET samples. So those come as part of the repo when you get it. And even if you're not going to look at the source code for Semantic Kernel itself, just having all of those samples is a good thing. Now on this slide, I talk about functions and skills, and I crossed out skills. That is a term that they kind of dropped. It used to be a collection of functions, like prompts was called the skill, and now they just call it a collection of functions. And that terminology even is changing a little bit, and they're starting to talk about them all as plugins in a way. So for now, we're going to call them functions. And A function can be done inline, so you can just make it up on the fly like we've done in the past. You know, here's the prompt text, stuff it in there. It can be an external function, so saved on disk, and this is where we get into that. Let's create a library of functions. So the way they do that is there's two files for each function. The first one is skprompt.txt, and that contains your actual prompt, and it's got the little placeholders in there for your parameters for your merge. And then there's another file called the config.json. And you'll notice when you're working with these semantic functions, if you're, say, going on the website and just typing some stuff in interactively, they'll give you the choice of setting some settings, and you can adjust those settings to work better with your prompt. And you'll see this like in Bing Chat. You know, if you go into Bing Chat, it says, okay, do I want this to be very precise, or do I want this to be sort of balanced, or do I want it to be very creative? And that's a setting called temperature, and we'll look at some examples of that later. And as you change that temperature, you can get wilder or more constrained responses. And depending on what you're asking it to do, it's a great thing to be able to change that setting. So if I'm doing poetry, I probably want it to be fairly hot, and I'm going to have that setting turned up fairly high. And if I'm asking for something, you know, as do I have time off on Christmas Eve, then I'm going to want that to be fairly cold, fairly low setting, because I don't want it to go off and make things up and be creative in that instance. So that's just one of the settings that you have available to you. So these two files are kind of used together, and they just set this up in a folder structure. And there's other ways to do this, and you can load these things from a database or however you want, but this is sort of the default that they give you out of the box, which is pretty nice because you can put these things on a file share, and your prompt engineers can engineer the prompts and tweak them a little bit and change the default settings. And of course, you can change the settings if you want later on to adjust them for your particular use, but there's some settings that work well with that prompt. So those are semantic functions, and we talked about native functions. This one at the bottom here, mycustomskill.cs. So that's when you write a function, and it's just, you know, a method in C# code. Let's take a look inside. So in those semantic functions, those two files, when you're loading them off disk, the first part is text. So it's kind of like a mail merge document, and that's the one called skprompt.txt. So here's a typical prompt. It generates excuses for your boss. It's been engineered by a prompt engineer, and it's shown to produce good results when paired with the appropriate settings. So this particular one gives what we call a one-shot example. They give one example of input and matching response, and then they get the next input. That's the one that's text merged in there, and the model knows from the example that it's supposed to generate a response in a similar way. So notice the input prompt. The user can provide a subject as a parameter, and the template engine fills that into the prompt, so it creates an excuse about a particular subject. We match that with another file, and that's the settings file. So it's config.json file, and it's just JSON, and it's got things like there's the temperature setting that we talked about. So this one is set to 0.5, so it's a setting between 0 and 1. Set it to 0.5, it's about halfway. So it's kind of a medium. And you can see some of the other options that are available here. So these settings tend to work well for this prompt. And what's really important, it's got a nice description on it. And there's a couple of reasons to have that description and why it's so important. One of them is that it helps document your code. So we said that these prompts are kind of like code. They're natural language code. So if you have a description on there, you're kind of doing some documentation. Also, if someone's trying to find a prompt, they can use these descriptions to figure out what's a good prompt to use. So this says basically what the prompt does. And what we'll see later on is that since we're using large language models, if we feed all these descriptions that are available into a large language model and we say we want to do this complex thing, it can figure out a series of steps based on these descriptions and do the work for us. So it's going to come up with a plan for us. We also talked about native functions. And this is just C#, and these are the most basic ones I could come up with. So there's a public string QWERTY, and it just returns the letters on the top row of the keyboard. Notice there's an input parameter. And again, that's just sort of the standard, is that most of these will take an input parameter. So they take a string coming in, they return a string going out. And we're getting a lot more features now where we can pass in, you've always been able to pass in any number of input parameters, but it basically always took those parameters generally as strings and returned a single string as the output. And what's interesting about that is that if you pass a string in as the input, you pass a string out as the output, it makes it easy to chain these functions. So I can make a function call, and this goes for semantic functions, the prompts, as well as the C# code. And I can say, well, here's my input parameter, and then its output becomes the input of the next call, whether it's C# or a prompt. And then that output can be used as the input for the next one, and you go on and on. So that's kind of why that's the default. But we're getting a lot fancier now, and we've got some capabilities that let us do more and not have to worry quite so much about taking an input string and returning a string as output. The thing that you have to have on here is an attribute. This is called SK function, and actually in the latest version it's called kernel function. So they did change that name, and you'll notice on here, just as important as it was for the prompts, we have a description, and that description does all the same things. So it allows us to document our code, it allows us to find things, and it allows planners later on to look at what's available and make plans for us. So what you're probably thinking about right now is, wow, this is C# code. So I can do anything in here. And yeah, that's the point. So a large language model is not going to be able to send an email for you, but as a C# coder, you can send emails. It's probably code you've written 100 times. And if you want to incorporate that, one way to do it is write it into your function, your C# code, make it so it can send an email, put a description on here, this is what it does, and then Semantic Kernel can call this. And so you can mix that semantic code with native code. So think about all of the things you can do in C#. Anything that you want to do can be thought of as a function or a plugin, and those plugins can work with the prompt plugins, with the semantic functions, and you can sort of interleave them and do all kinds of really cool stuff. Of course, in here, I don't need a temperature setting. I don't really need any kind of setting. I mean, what would the temperature do? If I wanted to have a setting like that, I guess I could and say, oh, let's be a little more random or a little less random, but that would be up to me to implement. So when we're talking about native functions, we're not really talking about having all those settings available. So again, pipelines or chaining is that string input, string output makes it pretty easy to just pass the output from a previous one along. So if I wanted to say, do an excuse for my boss, you know, and say, oh yeah, I was caught in a whirlpool on the way to work. But I wanted to say that in the voice of Yoda. I could chain these two things together. I could say, make my excuse, and then take that excuse, the output of that previous function, and put it into something that says, make this sound like Yoda, or do this in the voice of Yoda. So caught in a whirlpool on the way to work, my speedboat was. And that's just a really simple example of this ability to chain or build pipelines of functions. So that is mostly the slide portion. We got a few other slides here, but at this point, we're going to go ahead and do some examples. So I'm going to switch over to Visual Studio. And we'll look at some code. So this code is the simplest thing I could think of. It's just a console app. So I went in, said new console app. This is .NET 8 because that's the latest thing. And I went ahead and added some packages to it. I added Microsoft Extensions Logging Console. And the reason I did this, well, it's good to be able to log things, but also Semantic Kernel can use that logger to show you what it's doing. So if you're trying to troubleshoot things or figure out what's going on behind the scenes, you can turn on this logging and you can actually see what's going on. And they just use the standard logger. So in this case, I'm just using a console logger. And then I'll show you some examples where I pass that in and tell Semantic Kernel it can use that to output what's going on. Then there's Semantic Kernel itself. At this point, it's 1.0 RC3, so release candidate 3. And I have another thing for planners that is not quite working yet. Planners, they've separated them out recently, and this is an example of one of the planners that's available. So I'll show you that code, but I actually have to show you something, an older version of it in another project to show it working, because at this point it's just not working yet. And that's sort of to be expected when it's not quite to a version 1. Then there's Configuration Manager, and that's mainly just so that I can read some settings out of my config file. So these are the connection parameters that I use to connect to my Azure OpenAI instance. And I'll show you that in just a second. And the last one is system.link async. And this package just allows me to call things in a loop asynchronously. So get the first thing and then await the next thing and await the next thing. And the Semantic Kernel uses some of these things fairly often. So it's nice to be able to add that package, and that's how you make those things work. And we'll look at those as we get in there. All right, so my code is pretty straightforward. I did change this from returning void to an async task so that I can make asynchronous calls. I grab my stuff from my config file, and I do clear the console between every run so that we just don't have junk left over. But all the interesting stuff is in these methods. So here's one where we're going to do inline functions. So this is sort of the hello world of Semantic Kernel. And the way you work with Semantic Kernel is you build a kernel. So just like in ASP.NET, you have a builder to kind of build the host. You use a builder and you configure it. So we're going to make a kernel builder, and we're going to add some services. So this is the logging I was talking about. I can say add logging, and then I'm told to add the console logger, and that's where I need that, that package that we talked about a second ago. And then I'm going to add Azure OpenAI chat completion. So this is going to connect to my Azure OpenAI. And there's a couple parameters, and this just changed in the last version. So one thing they need is your deployment name. And then the other is which model that deployment name actually is based on. So you need those two pieces of information, and then your connection information, the URL to where it can find your Azure stuff, and an API key, which is kind of like your credentials to get into it. So we configure that, and then we build it. And then we have our prompt. So we're just creating a string, and we're saying, here's my input parameter. So whatever the user types, or whatever you want to use as your parameter goes in here, and it gets text merged in, and then it says rewrite the above in the style of Shakespeare. And optionally, you can have some settings. So in this case, I want to do a high temperature. So I'm just setting that particular setting. There's a bunch that you can use, but I'm creating these settings so that I can pass them in. If I don't pass anything, I just get the defaults. Which usually tend to work out. They're usually somewhere around the middle. So I've got my prompt, I've got my settings, like those two files that we looked at earlier, and then I say kernel create function from prompt. And I just pass in those two things, and it loads this into the kernel. So it hasn't done anything yet. It's just sort of loading my prompt and my execution settings in the kernel ready to go. And I get back this function name. So I've created this function and I've got a handle to it. And then I can call it. I can say kernel invoke async, or I could actually call it from the function itself, from Shakespeare function. I can invoke and pass the kernel in as a parameter, so I can do that either way. And I'm going to pass in my arguments. So in the past, this was just a string. Now it's actually a class, new kernel arguments. So you can have a collection of them, and there's an overload for the constructor if there's just one argument, the input argument. I can just pass that in there. So I take my function, I say here's the parameter that I'm passing in, and then I go ahead and run it. So let's see what that looks like. All right, this first part is the logging happening. So it gives me some information back. So it's telling me how many tokens were used in the prompt, so that I passed in, how many tokens came back from the response, and that's a total of 59. And tokens, if you're not familiar, is just a way of breaking down words into little chunks. And it's hard to explain exactly what it is. It's sort of a piece of a word. Sometimes one piece of punctuation can be an entire token. Sometimes an entire word is a token. Sometimes a part of a word is a token. I think rule of thumb is to say it's sort of like 1.5 tokens per word or something. But sometimes you need to know what these values are. And so it's nice to have logging that'll show you, and you can say, oh, it was 59 tokens. So that's what I'm going to get charged for when I get my bill from Azure, is this request cost me 59 tokens. And then there's some information about how long it took to run. So that's all very interesting, but here's the actual output. Verily, I am most enamored by the wondrous AI technologies that doth exist. So it took I'm so fascinated by all of the AI technologies, and it ran it through this prompt that we just created, this inline function, and said rewrite that in the style of Shakespeare and be pretty creative about it. So that's, again, that's sort of the hello world. So that's our inline function. So what is this Azure stuff we're actually connecting to? I'm going to switch over to that real quick. And this is the Azure OpenAI service. This is the OpenAI Studio that goes with it. And in here, you can actually try your chats. You can try your text completions. You'll see over on the right, it's, this is the model that I want to use, the deployment that's there. These are all those parameters. So here's my temperature parameter. So if I wanted to set that a little bit higher or a little bit lower, I can do that. So prompt engineers kind of live in here, and they develop the prompts, and they try out different prompts, and they get the prompt to be a little more cooperative by engineering the prompt and by adjusting these parameters. So you can play with it here, and these things are all on Azure. And the thing that's interesting about it is these deployments. So this is the one that I'm actually using, EPS chat test. And you can see that it's basically an instance of the GPT-3.5 turbo model. And I've done nothing to it. I just said I'm going to deploy it under this name. So you can create your own models, and you can tweak certain models so that you have a base model that's tweaked. But every instance that you create has a deployment name. So this is sort of like an endpoint. Which model am I going to connect to? And this is the model that underlies it. So that's what we're connecting to at this point. And there's an endpoint and an API key that connect me to this. And when I look at my settings in here, I said this is the deployment that I want, the instance of the model, and this is the actual underlying model. And then I give it my endpoint, my API key. So basic stuff. Let's get a little bit fancier. I'm just going to comment this out. and move on to this one. So basic functions. So all this stuff at the top, exact same. I'm going to turn off the logging so that it's not cluttering up the screen, but you can turn that on as you're working through things to figure out what's going on. So again, I'm creating an instance of my kernel, but this time, instead of going and saying, I'm going to just make up my prompt and settings and put them all in the code here, I've got these on disk. And so we've got a few examples. So in this plugins directory, in the fun subdirectory, so I'm just getting where the app is running, and when I compile, I just copy all these to the output folder. So it's going to find plugins and fun. And then it's going to load all of these up. So it's going to load up excuses, joke, limerick, everything that's in there. You can see some of these have quite a few functions in them. So if we were just going to do, an excuse, write me an excuse, it's going to load this prompt. So there's my input. And again, this has sort of been engineered, and you can see this is another one of those one-shot examples. So it gives you a one-shot prompt, a one example, and it says, okay, and now it's your turn. Here's what I'm asking or saying is the event, and you write an excuse, and that goes as the output. And then there's the configuration settings that go with it. So in this case, temperature is 0.5. It's got a nice description, creative or humorous excuse to send your boss. So it's going to load that up. It's going to load all three of these. In fact, it's going to load one that does jokes, one that does limericks. So this is kind of nice that you can load this whole set of things all at once. And then instead of creating that prompt like we did before from its basic functions, we've said, well, here's the path. So this is just the actual string, a path to go find these things to this fun folder. It says load everything you find in this directory. And so it's got all these folders with 2 files each, and they all load up in one shot. So these are the only ones we're going to need for this. But you can load as many of these as you like. I could load summarize and writer and however many I want. And then when I execute it, it's kind of the same thing. I'm calling invoke async, just like we did before. What it did when it loaded these functions is that it put them into a dictionary. So we've got this dictionary of all the functions, and I tell it which one I want. I want the excuses function. I want the joke function. I want the limerick function. And then we pass in our arguments. So in this case, it's hot. So that's the subject of my excuse. Is I want it to tell me that, something about it being hot. I want an excuse about that. So if we go ahead and run it, here's a lame excuse. Sorry I'm late. I was going to fry an egg on the sidewalk and got carried away with the heat. Okay, yeah, that's something. If I wanted it to be about, say, my cat, and Semantic Kernel is taking care of all the templating for me. So it's doing that. I don't have to write that text merge stuff. So my cat ate my homework. My cat is a genius and was trying to help me improve my grades by eating my homework and forcing me to redo it with more effort and creativity. All right, that's a pretty good excuse. And then we have it tell a joke. So we had it tell a joke about swimming. And what's a joke about swimming? Why did the lifeguard kick the elephants out of the pool? Because they kept dropping their trunks. All right, and then the third one is to do a limerick. So we're just calling each of these. And in this last case, there were actually 2 parameters. So I went ahead and set up my parameters. And I said, here are my kernel arguments. And instead of just using the constructor with one argument, I said, these are the 2 parameters that I'm needing to fill in. First one is name, and the second one is input, which in this case is the subject. And I call it the same way. So I'm calling the limerick function, passing those arguments in, and I'm getting back. Not sure where my bar went. I'm I'm getting back this limerick. So there once was a man named Mike whose love for airplanes was quite a hike. He flew every day, blah, 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 as you're doing. Okay, so that's something a little bit more intricate. We're doing some basic inline functions. The next thing is to talk about native functions. So this is your C# code. So let's take a look at the native function. And this is my C# function. You can see this is the new attribute, the kernel function instead of SK function, and I'm just using a description attribute. Make sure that I have a good description on this. So these are the ones that we saw earlier. And if I go ahead and call this, you'll notice that everything is pretty similar to what we did before. We've got our same builder. Everything is the same there. We're just saying that instead of loading these up from a path on disk or inlining them and creating them on the fly, I just want to load up this type. So my C# functions is the class, and it goes ahead and just loads up all the functions from that. And then all the individual functions, again, they're just in a dictionary. So I tell it which function I want to run. I pass my arguments in, and it goes ahead and runs that internal functions. So there's my function that returns the first row of the keyboard and my function that duplicates whatever I send it. So I said hello and it returned hello, hello. All right. What's next? Pipelines. So pipelines actually used to be a little bit easier. You used to be able to pass in an array of functions and it would just sort of execute them for you and expect that input parameter of into your first object, into your first function, and then the output of that becomes the input of the next one. So it's just changed a little bit in this last version. This again, all the same. We're just creating our kernel. Here again, I'm loading up the directory of functions. So these are my semantic functions. And I'm just loading up this time everything in the writer folder. So this whole set of functions are available to me when I load them. And then I'm telling it to go ahead and run these two. So write a short poem and then tell me more. So it's going to take the output of the short poem. It's going to become the input of tell me more. And the reason that that this used to be easy is also the reason that it doesn't work so well anymore, because it always expected that one input parameter is a string, the output is a string. It's not really the case anymore. So we're going to have to do a little bit more manual work. So I'm going to make my argument, my parameter, be the sky. So it's going to write me a poem about the sky. And then I'm just going to manually loop through my pipeline of functions, my array of functions. So the first one's going to be short poem. I invoke that function, and then I pass in my argument, the sky, and it's going to write me a poem about the sky. And then I'm going to make that, the result of that, the current argument so that it can be passed into the next one. So I'm going to write that result, so it'll write my poem out. Then it's going to go back and run through that loop, and it'll do the next function, which is tell me more. And this time through, my input, my argument, is going to be the output of the previous one. So it's going to tell me about the short poem. So I'm going to feed the poem itself in as the argument, have it tell me more about that poem. So let's see how that works. All right, the sky is a canvas so blue, and with clouds that float like a shoe. Sometimes it's gray and gloomy. So it wrote this little poem, and that's the output. That's the first console write line in that loop. So it did that for me. I gave it a subject and the sky, and it wrote me a poem. And then I took this poem, and that became part of the prompt, the input for the next one that said, you know, tell me more. And it said, tell me more about this. And I gave it the poem, and it tells me about the poem. The poem describes the sky as a canvas that is predominantly blue. So you can see how this pipeline idea is starting to build up. And we'll see this is sort of a very rudimentary planner. I've decided the steps that it's going to take. So very cool stuff, and that's how you can do some more complex things. And you'll notice as we're doing this, there's not a lot of code in any of this. You know, the actual code that you have to write is pretty small. There's the builder at the top, and you build that, and then you just go about loading up the functions you want and calling them. And it doesn't care if it's a native function or a semantic function. It treats them all the same way. You pass in parameters, it runs them. So it doesn't matter what kind of code it is. All right, the next one is about memory. And I said memory, we talked about grounding things and the RAG pattern, the retrieval augmented generation. So this one is a little bit different, and I actually have to exclude these warnings when I build it now, because they're getting close to V1 and they're saying these interfaces could change in the future. Not sure that they will, but they're just sort of warning you and making you know that, hey, these things might change. They're not quite as locked down as some of the other things. So I actually go into the project itself, and there's a pragma command that you can use to do this, but I chose to do it by having a property group and suppressing these warnings. So these are some new features that may change. So they'll be in V1, but you know, look out, they may not be completely stable yet. So this one, instead of being a kernel builder, is a memory builder, and used to be part of the kernel. Now it's separated so that you can get a little bit more flexibility with it and how you use it. So we're not actually going to have a kernel in this one. We're just going to use the memory builder and look at things you can do with storing memories. So in order to do that, you need to be able to take some text and tokenize it. So turn it into tokens, and then turn those tokens into vectors. And we're going to put them in a vector database. And you go, wait a minute, why are we doing all this? Well, that example where you want to see if you have Christmas Eve off. So let's say we have a PDF that's got our employee manual in it. There's a section in there about days off. Well, it might be called holidays. It might be called days off. It might be called, paid days off. We're not really sure. So if you want to look for that, you're going to be searching for keywords and trying to find something that matches. And they might call it something else completely. If you're in England, then when you talk about holidays, it's, they're talking about vacation. I'm going on holiday. So what we're really looking for is this way to search things semantically, or search by meaning. So not exact searches, but search by something that has a similar meaning. And one of the ways that we do that is that we can put things in a vector database. And vector database just means that things are tokenized and then they're turned into an arrays of decimal numbers. So they've got decimal points in them. And that array of decimal numbers sort of represents the text, the original text. And they store these things, these vectors, in a database. And then when you want to search it, instead of searching for specific text, you take your query and you do the same thing with it. You turn it into arrays of vectors. And you can use an algorithm to see things that are mathematically close in meaning. So if I say holiday or day off or vacation, those things have similar meanings. And so they're going to be mathematically closer to one another. So by storing things in this way in a vector database, you can search for the meaning of something instead of just the actual text in it. So in order to turn these things into those arrays of vectors, we have models that are good at doing that. So back in our AI portal, our OpenAI portal, there's a deployment called text embedding Ada 2, and it's actually just the deployment's named the same thing as the model itself. And it's really good at doing that. So we're going to load that up. So this is going to be able to connect to Azure, take some text that we send it, and turn it into vector arrays that we can put in our database. And then we have to tell it which database we're going to use. So I'm going to use one called volatile memory store. So this is just sort of a vector database in memory. There are a lot of vector databases out there. So there's a bunch of them hosted on Azure. You can use something like Pinecone, for example, and say, okay, I've got this Pinecone database. You can load your stuff into that vector database. Not quite as interesting for a sample. So here I'm just going to store it locally in memory. So I've just decided to do that. And just like before, I'm using that same builder pattern. So I configure it and I go ahead and build it. So now I've got this in-memory vector database and this way of changing text into vectors so that I can use the database. So that's what that's all about. And then I want to save some information. So information is saved in collections. So you can have a whole bunch of different collections that save different pieces of information about different things. So I've just made this string called about me collection, just about me, and I'm going to store a bunch of information into that one. So I tell it which collection I want to save it into. I give it the information I want it to save. And then this last part is kind of like a primary key in a database. You have to have some way of identifying it. So in this case, I'm just using strings and giving each one of them a unique identifier so that I can store these things. So I store a little bit of information about myself, and then I do that thing that I was talking about earlier where you're going to do a semantic search. So I'm going to search my memory, my vector database in memory, and I'm going to do a search on it and tell it, this is the collection I want, this is my question, do a search. And then I'm going to add this other optional parameter down here just for fun that says, in this case, I want to see the embeddings. I want to see the actual decimal numbers that it's storing that it turned my text into, just for grins. And remember I told you earlier about this async library that we added, the link async. So here's a case where it's going to return a bunch of results, and you have parameters that can tell it how many results. In this case, I'm just saying I want the first one and I want it asynchronously. So that's one of those cases where it's handy to have that available. So let's go ahead and run this. I'm going to store that information in my vector database. I'm going to do a search. I'm going to say, what's my name? And it should be able to pull that out. Okay, so there's my response, and I'll write that in a minute. We can see it here. The response is, my name is Mike. But what I wanted to show you was this response object itself. So when I passed in that with embeddings, it actually returned the embeddings. This is the information. So this is the my name is Mike. This is what it looks like in a semantic vector database. So that's what it turns it into. And then when I did the query, it found something that was mathematically close to this. When I said, what's my name? It turned that. So there was a bunch of vectors generated by this. It said, that's the closest thing. That's probably the answer. So it comes back and returns exactly what it says here. My name is Mike. So whatever you store in here, you're going to get the whole thing back. So as you ask questions, it does a search. It looks up this record and returns the information. But it doesn't return it based on keywords and matching text. It actually responds based on meaning. So let's go ahead and let that finish. And all right, so I ask, what's my name? And it says, my name is Mike. Where do I live? I live in Taos, New Mexico, and have since 2019. Again, that's the exact text that I stored in that database. So I can store basic text or chunks. I could say, like the employee manual, I could take each paragraph in the manual, chunk it off, and then when I ask a question, it'll pull back that section of the manual that's got the answer in, or the one that most closely matches. And you can have multiple matches, so it'll bring back as many as seem relevant. And you can actually say, I want up to this amount of relevance. So, I want 5 answers. And it returns that. So that's one type of doing the RAG pattern. So this is a way of using a semantic database and sort of building that into the kernel so that I can go out, look things up, and then stuff these responses into my prompt. Another section we haven't looked at the code for quite yet is with references. So it's pretty much the same. It's got the same ability to store some information, but you can also store a link. And in this case, I'm storing some websites. So I'm storing the Code Magazine website and the Better Homes and Garden website, and I'm storing some links, and here I'm just storing the home pages. Then I ask it a question, and I'm retrieving a little bit more information than I did above. I'm actually saying, well, what was the relevance? How relevant is that in answering my question? So let's take a look at that. So I'm saving a reference async instead of save info async. And it works the same. I tell it which collection, I give it some information. So in this case, I'm just doing some keywords. And then I actually store the reference itself, in this case, just a web link. And then I've got, again, sort of an ID down here. So then I ask it, what's good magazine for programmers? And do a search async. So just like before, this is the collection I want to search. This is my question. Here, I'm providing a few more of those optional parameters. So the next thing I set is my limit. So normally this would just return the top answer, but I'm telling it I want all the answers. I want up to 5. And then it's saying, what's the minimal relevance score? And I say, give me everything. So I don't care how relevant it is, I want the top 5 answers. Well, I only have 2 things in there, so I only got 2 things back. But you can see that in this case, I have pretty high relevance when I ask about a magazine for programmers, Code Magazine website. It matches those keywords pretty well. Better Homes and Gardens, not so much, so a little bit lower relevance. But I can see and I can make decisions based on that information about how much I want and how much I want to show. All right, so that's memories. And that's all pretty cool. Again, you're just going to retrieve the memories, and then you can stuff those responses into your prompts and say, base your answer on this information. Here's the information I looked up from the employee manual about days off and our holidays, and I want you to base your information on that. And it'll look in there and say, yes, you do have Christmas Eve off. All right, we talked about text chunkers. This is just one of the utilities that are part of the framework. So I have this big blob of text here, and I'm going to use this text chunker utility, and I'm going to say, okay, split that up. In this case, split it by lines or split it by paragraphs. And you've got some additional parameters here. You can say, what's the max number of tokens per line? Not words, but tokens. I could say up to 40. And if it's more than that, you're going to have to split it into 2. Or for a paragraph, up to 120 tokens. And if it's more than that, split it. And there's other parameters you can pass here. And it's just going to stop on the debugger break when we run it. And I can see my results from that bit of text above. I'll just view them. And you can see it did a pretty good job of splitting things into sentences. And it just took chunks of words. It said, up to 40 tokens. So it's breaking things down at a pretty low level. And if it gets more than the maximum of 40, it'll break over and roll into the next chunk. And I can also say, well, let's split this up into paragraphs. And we know each of these paragraphs is less than 120 tokens, except this last one. And that one got split into 2. So this one's a little bit better. It splits entire paragraphs. So that's a pretty good way to do chunking. We talked about maybe wanting to put some overlap in there. And that is some of the optional parameters that you can pass. We didn't show that in this example, but you can put in the number of tokens to overlap. That's just an example of some utilities that are really handy. And again, if you've done this for any amount of time, you've probably written a lot of this stuff by hand. The last thing I want to show is planners, and this is the one that's not going to run, but I do want to show it to you. So again, this is marked, it'll be in the V1 release, but it's marked as a warning that it may change in the future. This particular one I've been messing with, I'm getting it to use ChatGPT 4. So I had to actually use a different endpoint and API key to get to that. And I've tried it with 3.5, I've tried it with 4. Same kind of stuff here though, you're building the kernel, and then we're loading up a set of plugins. Again, we're loading up the writer plugins, and you can set up parameters and pass those into the planner itself. Now they've just, in this last week, decided that they're going to drop the original planners that they had and not use them anymore. And there's replacing 3 previous planners with 2 brand new planners. And the default planner is this one called Handlebars. Handlebars is a templating engine for JavaScript, and they use it. It's a templating engine that you can use in your prompts. So all these plugins, and it can do fancier things than just, you know, insert placeholders. So it can do things like loops and conditional branching, and so you can make some pretty sophisticated prompts with Handlebars. So that particular planner is based on the Handlebars library. So it's got all those things baked into it. And I was trying some interesting different variations here from my planner. But the way it works is you create an instance of the planner, the Handlebars planner in this case, and you say create a plan. And you pass in the kernel and the question that you want it to solve, and it'll come up with steps. And this part will actually run just fine. It'll output the steps. So it'll say, this is what I came up with for steps. But actually running it right now is the part that's not working. And this one doesn't take any parameters. So I still have to pass in an empty set of arguments. But I tell it to go invoke that plan, and we can see what happens here as we try and run it. And bring this down so that we can see it here. And this is the planners function from a previous version. So this is a different version of the SDK. And it works just a little bit different, but you can see that it's very similar. So we're building a kernel. In this case, I'm using the ChatGPT 3.5 Turbo. And I'm loading up the writer functions, and I'm going to skip over passing the configuration in there. But this was an older planner called the sequential planner. So this would just, you know, kind of like we saw with chaining earlier, pass from one thing to the next. So the sort of an equivalent planner to what we're working with. And we could do similar things, and we can say create a plan for this scenario, and then output the plan so that we can see what the plan was, and then go ahead and run the plan and write the result. So let's see if we can get this one to run. So let's try and run this. So first it's going to generate the plan, and it's going to show us the plan, and then it's going to actually run the plan and show us the result. So we can see initially that it came up with 3 steps, and it said, I'm going to use the brainstorm, and I'm going to brainstorm some ideas for Orlando. So it took my prompt where I said, my wife and I are in Orlando this week. I need to come up with a few date ideas and email them to her. And it looked at that prompt and said, okay, we need to come up with date ideas for Orlando. And I'm going to put that into the brainstorm. Then I'm going to take the result of that, and I'm going to run it through this acronym generator. And that's actually to take the placeholders in the email that it's writing and and flip them so that it says, hi, my love, and love you, me, instead of the placeholders. And then finally, it's going to do the email, and it's going to send the to my wife, and here's the input. So you can see it's actually doing LLM stuff as it goes along. And it's passing these, it's creating the parameters for us. So it's doing a pretty cool thing, and that it's using LLMs to take a look at all the things available to it and step by step kind of move through this and generate a result that fills your need. So it comes up with, hi, my love, I hope you're doing well. Share some date ideas for you. And so it talks about a boat tour and et cetera, et cetera. And I'll get different ideas each time this runs. So that's what the planners do. And you can see the power of the planners in that they read those descriptions that we have on all the functions that are available, all the plugins, everything that we can use. So a plugin might be some function that I create in C#. It might be a prompt. It might be something that someone else created. So I may be going out to, say, Bing and asking it to do a web search for me. Code, and it creates a manifest for it. And then it uses that information in the manifest to go out and call it. So that's sort of the OpenAI standard. And we'll take a look at some of those options here in a minute. So let me go back to my slideshow. And we'll talk about some of the things that we saw. So we did prompts, and that's enough to be dangerous with semantic kernel. That was sort of the hello world. But how could we be even more dangerous? So memories were that second big function that I talked about that you get. And you get really dangerous by the time you get through all of the functions. But we're able to take that RAG pattern and use it by doing memories. So here we're using memories with a vector database. So there's different ways to do memories. You can do just regular key value pairs. You can do local storage where you're storing things, and pulling them off a disk. And I think the one that's most interesting is the semantic memories. And you'll sometimes hear that referred to as embeddings. And that's the kind that we looked at. So we're storing some information, looking up the meaning of it, going into our vector databases, finding things similar, bringing them back so that we can put them into our prompt and ground our models so that we get good answers about our information, not just general things that are out there and available on the internet. So we looked at the memory examples, and we looked at chunkers that kind of go along with that. So that's a utility that you're probably going to be using if you're doing this kind of stuff. So gave you an example of that. And then the next thing was plugins, and I've just sort of glossed over this, but when third parties want to give you access to their systems, to the things that they can do, that's called a plugin. And this terminology is getting a little bit hazy now. It used to be that it's locally in something that you wrote, it's called a function, but if it's somewhere else and there's a manifest associated with it, you will look it up and connect to it, that's called a plugin. And now they're calling most everything plugins. So again, if you create a plugin and you want to make it available to the outside world and hook it up to, say, OpenAI, so that when you go to OpenAI, you can specify which plugins it's allowed to use, it can actually call your stuff. And Microsoft has done this with Microsoft 365 and Microsoft Graph and Bing. And Google has done it, Slack's done it. Everybody's got these plugins that you can hook into their systems and actually interact with. So it's just groups of native and semantic functions, and you expose them by creating this JSON manifest. And it follows the OpenAI plugin specification, and voila, your functions are now plugins. And anybody that you give access to can go ahead and use them. So it allows you to develop things that hook into these third-party things. So this is outside of your code typically. If you want to make plugin available to someone else, that's usually where the term plugin comes in. So that URL at the bottom there is the spec, and it tells you all about how to make these JSON files, the manifests that make that work. So something new out there is OpenAI came out with this idea of assistants. And in Semantic Kernel, assistants are basically done through the plugin model. And if you haven't heard of assistants, they're pretty cool. What it is you take a base model like GPT-3.5 Turbo or GPT-4, and you can provide it with some information. So you can upload some data to it and say, here's the data that you can pull from, just like we did with our memories. And then you can give it a specific persona. You can say, okay, here's a manual for rebuilding a Chevy 350 engine. And then you can tell it that, you are someone who's there to assist people in answering questions about rebuilding engines. And here specifically the Chevy 350 engine. And so you've got this data and you've kind of narrowed down what this model is going to do for you. And so it's like having a little expert. And you can even have several experts and coordinate them. So you can make one expert whose job is to basically coordinate among the other experts. So you can have like a researcher, you can have a technical person, you can have somebody who searches for things on the web. So you build these different assistants and then they'll sort of coordinate with one another to come up with an answer for you. So it's kind of like these planners that we talked about. It's going maybe even a little bit further than that. So this idea that you build this team of specialized people, and then when you're solving a problem, you can say, well, here's your team of specialized people, draw on them, let them do their thing. They can go out and call plugins, whatever they need to do, and they'll return an answer and coordinate with one another to solve the goal. Another thing that you can do with plugins, you can run local LLMs, like large language models. So Ollama is one example, and there's a sample out there that shows you how to set this up. So you set up Ollama on your Windows machine or your Mac, and you get it to run the LLM locally, and then you can build just this little veneer around it and use that as a plugin so that when you want to ask something of this local language model running on your machine, it can go and say, oh yeah, just like any other plugin, I'm going to go, and it's actually asking the LLM. So plugins are interesting, especially with assistants. There's a whole lot of things going on there, and it's a big thing right now. It's definitely going to be supported in Semantic Kernel. I'm sure there's some more refinements coming, but right now it's pretty well supported, which I'm pretty excited about. And then we talked about the planner, and again, this slide is an entire week old. So these are the old planners. The action planner, this is essentially a single thing. The sequential planner is the one that we looked at. And then there was the stepwise planner. That's the one that does planning incrementally. So it'll do a step or two, figure out where it is, and then decide what to do based on the things that happened in those previous steps. What's a good next step? And that's actually been replaced. So we saw the handlebars planner, and that's sort of the replacement for the sequential planner. And planners are really hot right now. That actually in the last couple days, these became deprecated and the others just sort of showed up. So pretty exciting what's going on with planners right now. But I think they're going to have that all pretty well nailed down in the next couple of weeks before V1 comes out. So the planner has, again, access to this predefined library of things that it can work with. And so you ask it a question and it goes out and figures out from that library, how do I accomplish this? And that's the general idea of a planner. And here's a little graphic that's getting kind of old now. It uses some older terminology, but it still kind of works. So you kind of work backwards. You say, what's my goal? That's the thing you're asking. So this, you start with the ask, and then the kernel loads up a planner, And the planner, in this case our handlebars planner, can make use of these other things. Skills, these are actually called functions now, or plugins, and memories. So that's our vector database in this case. And connectors, that's again, plugins, this ability to connect to outside systems. So it uses all those things and it comes up with an answer. It says, here's my plan, and it executes those steps and gives you an answer. So just to recap, big features, functions. So these are handling prompts in a generic way. It's the templating engine. Semantic functions, that's your code that's in your English language, or your native functions or code that are, in our case, C#. Then we have memory, so this ability to use large context to do grounding and say, okay, what I'm going to do is go look something up and then say, base your answer on this, so that we have this ability to do the retrieval augmented generation, the RAG pattern, and ground our answers. It's very important as developers. We can't just say, well, just only use what you find on the internet. We need this ability to inject stuff into it. And again, you can't just inject an entire manual. It's just too big. It doesn't work very well. So you chunk things up and you go through this process of finding the right material, putting it into your prompt, letting the LLM come up with a good answer for it. And then we talked about integrating with external tools and systems, plugins. So that is this ability to do other things than just generate text, which is what LLMs do. So working with the outside world. And then finally, that ability to chain prompts together to achieve a goal planner. So these are the four big areas in Semantic Kernel. And there's a lot of overlap with LangChain. There's some differences as well. But these are the things that you'll be interested in. So that's kind of the end of the talk. We'll do questions here in a minute. I wanted to say that if you are interested in these sessions and other training sessions, youtube.com/codemagazine, and we've got tons of material out there. The recordings and the slide deck, you're going to be able to find those at codemag.com/codepresents, and those will be posted after the session. And we're ready for Q&A.